You guys ready to roll? All right, cool. So good news, you don't have to model along or do any work. I'm assigning no homework or nothing to follow along. We just kind of hang out and we'll kind of look at some SketchUp models together and some projects and share some fun and some heartbreaking stories. So for those of you that don't know me, I build things. Some of the things that I build are for SketchUp, some of them are not. But what almost every one of my projects has in common is that SketchUp was used for all of the communication, all of the figuring out how stuff goes together, and all of the fabrication of all of these projects. So what I thought, I just picked a couple projects out of my portfolio, and I thought I'd go through and sort of tell you a little bit about them and show you how they were constructed, both physically and in SketchUp, so you can kind of see how this all works. So the first one here, this is a project that I affectionately call the Rage Booth, but this is actually a soundproof phone booth for a co-working space. So the idea is, kind of like an open office plan. If you need to make a phone call or just in general be loud and disruptive to other people, you can go inside this little box and you can close yourself off, and it's soundproof. So I'm actually just going to jump right. Can I get out of this thing here? Yeah, we'll go right over to SketchUp. So this was completely designed and figured out in SketchUp. So the owner of the co-working space approached me and said they wanted one of these things. They looked at some of the off-the-shelf, kind of pre-made units, and they were really expensive and didn't quite have the look and the feel that they wanted. So they said, hey, can you design one of these things up? So I did a really rudimentary SketchUp model. Kind of blocky, but just sort of get a feel for the size and sort of the overall look. And then I just kept dialing it in until we got the final model, which is what you see here. And you'll see a lot of my models, they're kind of messy. I keep like spare parts all over the place. I didn't want to like clean these up or edit them. I wanted you guys to see like how actual real model took place. So typically the way these models go is I'll have one sort of master master model. So this is like the fully assembled part. And then a lot of the separate parts I'll sort of lay out across the model if I need to work on them individually. So these are some of the interior panels that you see in here with all the holes in them. And we've got the roof panel, the shelf, and some of these exterior panels. And so the way this project works, so I design these things and then I go into the shop and I fabricate all of these things. So this thing was built using some 80-20 aluminum extrusion. Has anyone ever seen this stuff? So if you're like a geek and you like building stuff and like maybe you use like Legos as a kid, this is like adult Legos. It's awesome. You can build like robots and machines and structures and all kinds of stuff. And if you're like even moderately into Legos, go to the 80-20 website and you'll kind of get geeked out and then try to order something and you'll be totally shocked at how expensive they are compared to Legos, but still very cool. So I actually went and I went to their website and I downloaded some of the profiles and I started building let's see if I can do the metal frame here. So I started building the metal frame in SketchUp, and these are just simple extrusions, simple miter cuts. There's really no fancy SketchUp work going on here. What I learned at the 80-20 website is that you have to order a lot of it for their engineers to help you figure out what you need. And if you're under a certain amount, they're like, hey, you can order whatever you want, but you're like kind of on your own. And I had never worked with this stuff before, so I really wanted to like put it together in 3D to really figure out how it was all going to go together. So because we have this frame, there's a door that swings open, so we've got some hinges over here on one of these sides. And then there's all these little blocks that are in here that kind of you bolt the panels to, and on the inside's this kind of soundproof insulation. So I spent a lot of time sort of assembling, downloading different components, kind of fitting them all together like Legos. I probably had, 5 to 8 to 10 hours into sort of figuring this all out. And so then I was ready to place my 80-20 order, and this is where a little bit of the heartbreak comes in. So I got their order form and I filled out all the things that I need. And because I'm kind of a woodworker, you always think of like getting lumber and things like that. You do what's called rough cutting. So you get stuff a little longer and then you put it on a really accurate saw and you chop it to just the right length. So I kind of had that same thought process with this aluminum. So I thought, okay, I'll order all these like kind of extra long pieces. I'll get like a special aluminum saw and I'll cut it down really accurately. Turns out when I submitted my form to 80-20, they called back and they said, guess what? You get free engineering because you're about to order enough stuff. So they figured out the whole thing for me anyway. So I spent all this time in SketchUp figuring it out, almost for naught. But it turned out that this is a little bit more complicated than some of their typical orders. And I was actually able to send the engineer this model. And it was funny, they don't use SketchUp there as their standard program. They're more into SolidWorks. And I actually said, look, you can use SolidWorks, just I can't get this into SolidWorks for you. I said, just download SketchUp. You can just use the Orbit tool, look around, and they actually did it and was able to get this thing ordered for me. So all of my parts showed up absolutely perfectly on the first try. So that was really cool. So then the next part of it, so we have this metal frame. So we can zoom this in a little bit. Get the metal frame up, and all of the panels that are on the inside. So if we jump, can I go back over to the, this thing does not like to shift on. So there's these wood interior panels like this that are full of all these holes, and there's a little bit of carpet underneath here, and there's some furniture and this little shelf. And all of these things were designed really, really accurately, exactly as they're going to exist in real life. And this is probably a little bit hard to see, but even down to like getting just these exact little mitered corners in there. Everything is just right. All of the holes where these panels bolt in are all modeled exactly in SketchUp. And the reason being is I have a CNC machine. So I can take full sheets of plywood or plastic or metal, lay these sheets down on the machine, and I can actually send a SketchUp model in there, and I can cut out these parts really, really accurately. So how many people were in the CNC class I did? Anyone? Okay. So there's a method that you can get, and if you guys have questions on this, I can show you later. There's a method that you can get pretty much any geometry out of SketchUp and get it right into a CNC machine. So what I noticed when I got these metal frames, that they were super, super accurate, right? And a CNC machine, it's a robotic cutter, right? It is super, super accurate. So when we had this frame built up and we started putting these panels on, everything fit just perfectly. And again, this is all from the SketchUp model. So at this point, things were going very, very well, okay? Now, you may notice all of these holes that are in these panels here. So Grant, in his keynote, talked a little bit about the scientific method, and we employed the scientific method when designing and building this booth. Because I'd never built one of these things before, and it's supposed to be as soundproof as possible, I built a small scale version of it, okay? So it's a little like 12-inch by 12-inch box. I put a Bluetooth speaker in it, and we were testing. One of the things that we were very worried about was this panel in the front here. This is a Lexan panel, so we didn't want people to feel like super claustrophobic inside this thing. And I was concerned that the plastic was gonna let a lot of sound through it because it's such a big, area without soundproofing in it. So had this box, put the speaker in there, ran a certain song in a certain volume, had a microphone rig, we were testing the decibel levels, and I tested all of these materials on the opening. It turns out plastic is actually a pretty good sound insulator. And really the lesson that we learned, so if you had the plastic on top of the box and you lifted it ever so slightly, if there's a little crack in there, sound likes to escape through air leaks, right? So that sort of informed the way that we were going to build this. So the inside of the frame was all filled with the soundproof panel. It was all kind of airtight, and we sealed it up with foam and things like that. And then at the last minute, somebody, and I won't name any names, but somebody thought, man, wouldn't it be really cool if we had this super cool pattern of holes that we could drill in these back panels to give it this neat look. So if we go back to the final picture here, you'll see all these holes in this panel. And I was like, yeah, this will be a great idea. We'll drill all these holes in there. It'll look super awesome, give it some nice texture. And for some reason, we all thought that if the sound goes through the holes, it's gonna go into the wall and into the foam, and it'll just go away, right? It'll be even better. So we just took all the science we did, threw it out the window. The machine that I have, you put the sheets down, it's got an air drill. So this is like 1,800 holes per panel, so just shy of 6,000 holes that were in this thing. All day, I'm watching the machine go, drill these panels. So I had a helper in the shop. He came over and we kind of put this thing all together. And there was that moment where we put the door on. We had the glass all mounted in. I'm like, all right, Patrick, go stand inside, shut the door, and start talking. And he stands inside and shuts the door. And I'm like, wow, you're actually louder when you're in that booth than, yeah. I was and I'm going, oh my God, this thing's already behind schedule. And we just totally ruined it by drilling all these holes in there. So we ended up, I ended up finding this really, really heavy duty and really expensive rubber, it's like rubber sheet, but it's specifically meant for sound damping. And I think it's actually in the SketchUp model. So I went back, and because I thought, geez, I really have to, yeah, here it is here. So I have to like save this thing, right? So I'm kind of faced with things wired, it's all assembled, they're waiting for it. And so I thought, okay, let me order a bunch of this rubber sheeting. And if we look at this model here, and I kind of take this, this panel off, you can see underneath, there's now this black rubber sheeting. So I decided to unbolt all the exterior panels, pretty easy to do. I drew the rubber sheet in SketchUp, and I actually put the rubber sheet on the CNC machine, had it cut out the profiles of the sheet because I didn't want to see the rubber from the outside. I was able to take the panels off, hang the rubber on there, bolt the panels back on, and thankfully it was very nice and very soundproof after that. It also got really heavy. Those rolls of rubber were incredibly heavy, but we got it done. So what happened, and obviously I told the people that I was building this for what was going on, and they were concerned that this could change the look of it, or their ability to move it around or put it together. And luckily they were SketchUp users as well, so I was able to say, here are the changes. And I sent them this SketchUp model, and they said, well, I can't even see the changes. And I said, yeah, because it's just a thin sheet of rubber back here. They thought that was fine. So this was a project that, this was solely designed and solely fabricated completely off of SketchUp models. So let's move on to this one. Anyone remember these? Did these a couple years ago at Maker Faire. So. A little inside baseball on this story. So who has been to or heard of Maker Faire? Okay, so for those of you that have not, it's like the world's biggest show and tell. For a number of years, SketchUp went there because they like to show off cool things with SketchUp. And what they really, really encourage you to do, so like SketchUp's they're renting a booth, they're advertising for SketchUp. And what they really encourage these companies to do is when you go to Maker Faire, because it's like this big show and tell, you really don't want you to like take just your stock corporate booth. They want you to like make something, right? There was another vendor next to us that had, or a TV, it was LG or something like that, had a whole booth made out of like old pallets that were like duct taped together in this like very clever way. It was really, really cool stuff. So we had a pretty short deadline to put something together. We had, I think it was a 40 by 20, I think. Yeah, because these were two 20-foot diameter domes. So we came up with the idea of doing geodesic domes. And as with all projects, by the time we got the idea to do it, we had grand ideas of constructing these big wooden structures, and we had like 5 weeks from the time they were like, yes, geodesic domes, to they needed to be like at Maker Faire. So I kind of doing some head scratching. I thought, okay, what's the cheapest, lightest, fastest material we could use? Plumbing pipe, right? Drain pipe. It's all made out of drain pipe. It's all underneath your sink. So what I did is I went into SketchUp and I actually went to 3D Warehouse and started downloading some geodesic dome models to kind of figure out how they all worked. And as we've all seen, like Epcot Center is like a very smooth geodesic dome. There's some geodesic houses near where I live, but they're very, very triangular. And I'm not an architect, so I didn't really understand the difference. So I just started downloading these models and kind of figuring out, what made a smooth dome and what made kind of a bumpy dome. And it turns out that it's called different tessellations. So you can have like a 2V, a 3V, a 4V, or a 5V, or a 6V dome. I think Epcot is like a 5 or a 6V, so it's got lots of little triangles that make it smooth. Our dome was a 3V dome, which essentially means that we have 3 different lengths of pipe. And they're labeled here, blue and red and yellow. And you can see I went to all the effort of even putting the little labels on there. Well, I wanted to make it, and being like, Centerpoint, and this is SketchUp, like they know, we were making makery things, but one of the things I didn't want to do was strip all of the labeling off of these pipes. And it's like a maker event where like duct tape is an incredibly acceptable building medium there. And so that like labels would be cool, but I wanted to make sure that everybody understood that there are labels on there, because if someone was like, hey, why don't you wipe all the labels off? It's like days worth of work on this amount of pipe. So it was like, it's kind of kitschy and fun, but it also actually had a purpose there too. So these were designed in SketchUp. I used Follow Me tool, I used Profile Builder, a bunch of wacky tools and extensions to kind of put this together. And this is what we kind of ultimately went back and forth on and we agreed on, because when you do events like this, you have to be really clear about what you're doing. I mean, Maker Faire is like an incredibly awesome and really dangerous place as well. They have full-size mousetrap there. Like they smash a car at the end of the mousetrap. Like that's the level of like awesome / danger that's there. And so when you do stuff like that, they don't just let anybody show up and say, yeah, we're going to smash a car. You have to send detailed plans about what you're going to do. And we really had to like articulate that this was going to be like strong and that people were not going to allow people to climb on it. And if somebody does climb on it, is it going to fall over? And all these type of questions. And you can answer them really well with a 3D model. So this is sort of the hero model. And then, so the other part of this is we wanted a roof because it always rains at Maker Faire. For whatever reason, it always rains in the first day. And we had total stations, we had computers and all that stuff in there. So we wanted some covers and we didn't want to just like throw a tarp over it. So we contacted a sign company and who makes those like vinyl hanging signs. And we thought, okay, they make vinyl signs, they can print stuff on them and they can cut them to shape. So maybe that they could make these shapes. So we called them up and said, hey, could you cover a dome like this? And they said, yeah, sure. If you give us a shape, we could maybe do that, but we have no idea how to do that. So then I was like, well, I guess we need to figure out how to do that. So these were drawn. These were drawn with kind of smooth vectors. So we ended up doing, I think they're in this model. Let's see if we have the gore plan. This actually might have been in a different file. Oh, here we go, flattened gores. So I made a bunch of simple triangles and I kind of took them into SketchUp and I folded them so they would make a dome. And I separated them into these pieces like this. And we actually sent them a layout document with like the heights and the widths of all these. And once I sent them this file, they're like, oh, okay, we get that. We can make triangles with little lines. We're cool. If you can just tell us the size of the triangles, we got this. So I ended up sending them, I actually exported the SketchUp model as a DXF file, and they've got these big, crazy robotic machines that can cut stuff out, and they use the DXF file from this SketchUp model to make the tarp covers, which we ended up having here. And they were able to print the logos on it and stuff, and they actually fit, which was really great. And so we had all that stuff worked out. So we're like, okay, we know how to fabricate this. We know the material that we're gonna use for the framing, and we know the material we're gonna use for the covers. We had to get it approved by Maker Faire. So we had to do a site plan. Now this is nothing like I was just in Dan Tall's landscape architecture class. I'm a very, 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 very amateur landscape architect. This is about the extent of it. But this was our plot that we had. It's in a parking lot, and there actually is a little island here. And we showed this to the Maker Faire staff. I said, look, that's where we're going to put our domes. They're going to fit in our rented space. And they said, that's great. So so this is all fun and games. Right now it was time to actually build these things. So there are 3 lengths of pipe. And there are a lot of them, and the lengths are pretty specific. 37.83, 44.43, and 45.49. These are the amounts of all the pipes and the totals. This is just for 1 dome, I believe, or 2 domes. But suffice it to say, this is a lot of pipe. And I wanted to errors accumulate on stuff like this. So if I was a 1/4 of an inch off on each pipe and you start putting these things together, by the time you get around to the other side, like your dome won't go together. That's bad news. So I needed to do 2 things. I needed to cut all the pipes the correct length, and I needed to get the correct amount of pipes. And I'm very glad that I spent a lot of time in the SketchUp model figuring this out. So this is actually from, I did a generate report in SketchUp. So all of these pipes that are in here are just simple components, but they have their axis oriented all the same way. The blue, if I remember right, yeah, the blue axis runs down the length of every pipe in here. And what that allowed me to do was do a generate report, so I could get a report of how many pipe components I had and the length of all of those. And so I essentially used that to add up like the total length of pipe that I needed, account for some waste, and then go into Home Depot. I think I ordered 1,200 pipes. You know, when you go like, and they've got like they sell them in like 12 foot, over in the plumbing section. I went over, I think I needed like, I don't know, it was like 600 pipes or something. I went over and counted, they had 32 on the, in there. And I was a little ahead of schedule, so I go over, I'm like, okay, what would I need to do to get 600 pipes? And the guy's like, 600 feet? Because like, I think we have 600 feet. I'm like, no. I need like 600 pipes, like 610 footers or whatever it was. And I had to say to him like 3 times, he's like, oh, you're serious? And he's like, hold on. And so he goes back and he's like, well, we've got some in this store, we've got some in this store and this other store, and everything we have should be enough. And they actually sent trucks and they pulled them from all these different stores. So for like 2 weeks, I think every plumber was really upset at me because no one could fix a drain pipe. So there were several truckloads of pipe. This was the first sort of test load. At the time, I'm very lucky, I've got a very nice big shop now, but at the time, this was my shop. This is my brother's single car garage that I kicked him out of for a couple weeks to build these, and it very quickly turned into Pipe Fabrication Central. If anyone's ever used the chop saw and thought it was fun, it's not after you cut this many pipes. Especially, I blew up a chop saw in the middle of this thing too, and this isn't even the half of it. This was like a 4 foot by 4 foot crate, because we did 2 of these, and we made a bunch of PVC furniture, and I even made PVC chandeliers, because why not? I had all this pipe, and this was just so much pipe. Now, not having a shop, I was testing everything as I went along, right? So the SketchUp model was super accurate. I checked the report. I cut sections of pipe, because I had 3 lengths, so I do, little test sections. I go back and I was like obsessively making sure that these were the right length, because if I set the saw wrong and I cut 50 pipes, errors in this thing scale a lot, right? And so the thing that I didn't yet know was how or if this was going to actually work when I put it together. I was pretty convinced, because I'm looking at the SketchUp model. I saw some other people on YouTube putting them together, but you got to actually test it, right? So at this time, I didn't have any property to test this on, or a big shop to put it in, and I live on a school campus. My fiance is a science teacher, so we live in an apartment on the campus, so we don't have land, right? So we asked our neighbor, who's the dean of students, we said, hey, if we were to set this up in the yard for a couple days, is that cool? And he's like, yeah, no problem, I'll clear with the administration, it's fine. So this is us out in the yard setting up one of the domes. It was really fun to put together. Megan and I put it together ourselves, only using 1 ladder and a couple of rubber mallets, and it went together really fast, and it's crazy strong, right? So we put this thing up, and we're right out of our kitchen window, we have this 20-foot diameter geodesic dome. It was a great couple weeks. Well, turns out the guy who told us that we were allowed to put it up didn't actually clear it with the administration or tell anybody else on campus, and it caused all kinds of drama, and we ended up having to take the dome down. But I was able to test it, and this turned into a pretty cool project. We actually used this a bunch of times. We used it at Maker Faire a couple times. These are trimble dimensions, and I think it's actually it still resides at SketchUp. So, yeah, question.
What did you use for a connector?
Yeah, it's a really good question. So I had actually designed a connector out of PVC pipe. What I was actually going to do, I had this I was going to cut, if this is a circle, I was going to sort of whack off the bottom of the circle, so it was like that, and then bring a bunch of these things together and kind of crush them together with bolts, so you can bend them around. And to be honest, I didn't have enough time to fabricate them all, because it required a lot of handwork. I actually ended up using a pre-made hub from this company called Sonostar Hub, that they have a mold that fits these pipes. And this is really, because I had 5 weeks from the time that we came up with this idea to doing it, and they made them and shipped them all out to me really fast. And I don't know if I have a close-up picture. Actually, I do in the SketchUp model, because the hubs are in there. So these hubs kind of fit together like this. I don't know why that one's off a little bit. I do know why that one's off a little bit. I will share why. Yeah, so the pipe should snap over the hubs, and you put a bolt through it, and it would hold tight there. This thing was crazy, crazy strong. I mean, these pipes, when you pick them up, you can take one of these pipes and kind of bend it over your knee like this. When you put this thing together, we had 15 of us standing on this thing, and it wasn't flexing at all. It's Bucky Fuller, man, he had this figured out. So the misalignment in these pipes here, I am not going to make an attempt to try to explain the math behind this, but essentially it has something to do with, this is more than a half of a dome. Okay, so it's like a half of a dome, plus some, and that's what gives it the height, so you can kind of walk around inside it. And so essentially, in a circle, you've got 360 degrees, but then you've got a dome, which also has 360 degrees, but we had a little more. So the math actually doesn't work. So all of these pipes in SketchUp were totally straight. And the reality of how these structures go together is when you're building them, you have to have a little give in whatever material that you're using, which luckily I read about and knew. But the SketchUp model really exposed the amounts of sort of that this was off. But it does work. It totally goes together, and you can tell like when like that pipe there that was missing line, you just kind of got to pull it over and sort of pop it in place. But this is a super fun. This is a super fun design to create.
Itself is fairly flat.
What's that?
The hub itself is flat.
No, they all had some angles on them. Yeah, they had a little camber. And what's funny is, and this is like, again, I'm not like claiming to understand all the math. The camber angle does not change if you're making a little tiny dome or like a 100-foot one. It's the same angle. Geodesic dome's really, really awesome. And what really was kind of like a humbling, experience going through. I had pre-made models that I could work from. This has been researched to no end. Geodesic domes. I have this great piece of modeling software to like figure all this stuff out and to keep me accurate. And like, Bucky Fuller, man, he just like did it with pencil and paper. Like, seriously, it really made me respect that type of stuff a lot more. So this was another one. So at the who's going to the Desert Glow party tonight? Everybody, right? Okay. So there's going to be tons of cool stuff, some surprises, that sort of thing. But one of my projects will be out there. So not this Basecamp, but the last Basecamp. Somebody at SketchUp called me up and they said, hey, could you just like make us a quick set of cornhole tables, and then like, I know this is like kind of below you because all the cornhole table is like a rectangle with a hole cut in it and some legs sticking out the back. And I was like, yeah, I can do that. And rather than like make them basic, I wanted to make them the most complicated and the most complicated cornhole tables ever created. So I went into SketchUp and I modeled these up. So what they wanted was, they wanted a cornhole table, had some nice plywood with the Basecamp logo on it. So this is accurately modeled. All of the plywood parts, all the vectors were extracted from those and they were all CNC cut. So this thing came off of my machine like ready to assemble together, just needed a little sanding. And I've got a vinyl graphics guy who does all my graphics for me. And so this is actually modeled using real SketchUp vectors. So I export these vectors and I send them to him. He's got a big vinyl cutter and he makes me these stickers. And so I can like tie everything together. So I can set up all the graphics, get everything, just the way that I like them. And he loves it because he's like, you're my greatest customer. You come to me with ready files and all I have to do is like put them in my machine and make them. And he comes over and sticks them on for me. Now, where this thing gets complicated is if you look closely, we've got a score on here. And if we look even more closely, there is an LED strip in there that, so there's a way on the back, there's some buttons, and you can press the buttons, and you can keep score. So you can add the score up and down, because I don't know about any of you guys, but I'm in a certain state oftentimes when I'm playing cornhole, and maybe the memory isn't working so well, so I wanted this way of sort of keeping score. So then I thought, well, could we do more? Could we make this more crazy and more complicated? Because like LEDs, cool, kind of easy to do. And so I thought, well, okay, so you have these buttons, and the LEDs go up and down, but then you've got two boards, right? So then the score can be off, and then maybe there could be an argument about which is the accurate score. So I thought, okay, well, is there a way that we could get one board to talk to the other board? Turns out there is a way. And I thought, okay, well, when like a cornhole, when a bag lands on the deck, could it like flash and do something? Turns out you can do that too. I wanted, when a game was won, I wanted to do this kind of light show, right? So I called up a friend of mine who works at SparkFun, and if you look, and feel free to pick up one of these and turn it over, but if you look underneath, there is, I think, the most electronics ever installed in a cornhole game ever. So this has an Arduino board. It actually has we didn't get the speaker in there, but it actually has a sound emitter. It's got a power supply for a whole bunch of LEDs. It's got a light up circle, and then the channels on there, the two switches. An accelerometer, an RFID reader, and a wireless connectivity board. So when you plug these things in and turn them on, they wirelessly connect to each other, and no matter which board you're on, you can run the score up and down, and it will synchronize across both boards. And when there's a winning score entered, both the boards go crazy and the lights flash, and it's pretty fun. So I came up with the idea for this. And the part that I can do is like, I can cut all the wood parts and get all the graphics on there. So when I called Spark Fun, my friend Brian over there, he's like, okay, I'm into this. Like, I think we could do it. But he's kind of like a typical engineer. He was getting all obsessed with like, well, okay, like, well, what about the LEDs? You know, because I need to know exactly how many LEDs to light up, you know, for each score, right? And I was like, don't worry about it, it'll be fine. Just make it go up and down, and I'll put the stickers wherever. And he was like, no, I need to know how many LEDs. Because I'm like trying to be flexible, right? I'm like, just do what you do. Just make electronics. I'll figure out stickers, right? And he's like, no, you got to tell me. So he's in Colorado. I'm in Massachusetts, right? So I said, look, if you can tell me the spacing on the LEDs, the exact width of the LED strip, I will model it for you so that we can have this figured out. Because I made these things and I sent them to him, and he actually installed all the LED strips. So we had to make sure that channel was exactly the right width. And I put the stickers on. He had no way to put stickers on. So I thought, okay, I agree with you. We should really figure out the spacing for the, you know, for the LEDs. So I had the stickers put on in exactly the right spot. So when he got this thing, he was able to pull them out of the crate, lay the LED tracks in there. He had pre-done all the electronics, even down to the point where I got all of the diameters of the switches that he was going to use. So he had everything all set. So he pulled these out of the crate, popped these all in an hour. He had these things up and running, and we shipped them off to Basecamp. And this wouldn't have been possible. It could have been possible. It was so much easier because we had this like kind of canonical SketchUp model, you know, to work from. So, you know, again, kind of using the SketchUp as the center point of design. It was really, really helpful in this. And so tonight, go play some Cornhole, and now you know the whole story behind them. And this really, truly, I think, is, you know, made in SketchUp, right? Any questions on that one?
When you finish the model, you export that into the DSF or PNG for them?
Yeah, so multiple different formats. So I sent Brian a layout document, just had all the spacing and stuff, so he could confirm, you know, the amount of LEDs he needed to light up for each score. And it made him feel better, you know, that I had it all laid out for him. For the CNC machine, there's actually a bunch of different ways you can export vectors out of here. When I did this one, the typical workflow, let's see if it's the same in this one. Typical workflow is to just put on layers the vectors that you need to cut out. And what I mean by that is, like, this is a 3D model, obviously. For all intents and purposes on a CNC machine, this is a two-dimensional cut. So, like, to cut out the main board, really all I needed was the circle for the hole, the rectangle for the outside, and the rectangles that make up the channels. So I would put those vectors on a layer called like cutout or something like that. I would turn off all the other layers and only export those. Because in the case of a CNC machine, you've got to go to like another program called CAM software. And the less cleanup you have to do of extra vectors in there, the better. So I like to kind of separate those out. But I do that right before I'm about to make it, because it's like always right to the last minute. You're messing around with the model, so I do it like at the last minute. Same with the graphics. So what I would do with the graphics, I would do DXF for the vinyl guy. But of course, the DXF, you get the cuts, but you don't get the colors. So I would give him a DXF file, and I would print him out. He's a little old school, he likes printed stuff. So I give him the DXF file, and I would print him out a layout document that said, you know, this is what it is, this is the overall size, just so he can check to make sure his vinyl cutter is doing the right thing, and of course the colors, because we had to get these colors right. That is a very good question. By show of hands, how many people have exported an AutoCAD file out of SketchUp and been stymied by the jagged arc thing? Has that happened to anyone? All right, okay. Maybe like ask me after, because I have another project I want to show you guys, but this is, if you do, okay, so the way that you'd think that you should do this, like for this graphic, is to do file, export, 2D graphic, right? Pick DXF or DWG, and that's like the obvious choice, right? You're getting, this is a two-dimensional thing. So here, let's just do this on a much simpler model, and so I don't wreck this model. So, okay. This might be, if this is a problem that you've experienced before, this might be that thing that you will come away from Basecamp and go, oh my God, that was amazing. Okay. So here we go. We have a SketchUp arc, and if we extrude it and kind of turn on hidden geometry just to really exacerbate the problem, we know SketchUp likes to do this to arcs. So you can increase the amount of sides that are on this arc, and you can increase it to a point where it appears that it's actually smooth, but it's really not. It's still a bunch of jagged arcs. Now, starting in SketchUp 2017, I think, they got much better at tracking arcs. So what I mean by that is if we go, arcs and circles. So if we go to entity info, that's like, properties, you can see that this, we have some information about this arc that I've selected. Layer, relevant, radius, this is very important. This arc has a radius, okay? If I export this, if I needed you to cut out this curve thing for me, if I export this as a 2D graphic, you are going to get a segmented arc, right? If I export this as a 3D, DWG, or DXF, SketchUp will actually export an arc with an embedded radius. So when you open it in another piece of software like AutoCAD or your CNC milling software or vinyl software that can read arcs, and that is most 2D programs, it will read that arc information and rebuild you a smooth arc. So that's like pro level tip. I accidentally discovered that and I was like, oh my God, this is it. This is it. Doesn't matter. So it's a great question. So you could actually have this if you made it, because an arc is a start point and end point, and then the bulge, right? That I like to call it. So you could actually have, like if I turn this down to 3 segments, this still technically has a radius, right? So if you export this out of SketchUp as a 3D, DWG, or DXF, you will get a smooth arc in another program that can read an arc. And so it's a little counterintuitive, right? Because I make 2D drawings, but I'm exporting them as a 3D DWG, but I'm only selecting the 2D vectors. Does that make sense? Question in the back?
Yeah, so it has to be three-dimensional to do that?
Yeah. Okay. So it's a weird thing to wrap your head around. So a 2D file export 2D in SketchUp. Whatever view you have, it's going to give you a 2D version of that view. If you hide all the vectors that you don't need, so like in the case of the cornhole table, rectangle and circle in the middle. If only those vectors are on the screen, and I go File, Export, 3D, DWG, or DXF, I'm only getting those vectors, so it is a 2D drawing, but SketchUp is exporting a 3D DWG, and that is the only mode that you get the smooth arc in. I totally found it out by accident. Because what I would do is, like, when I go to the vinyl software or the CAM software, I just deal with the segmented arcs. I would delete them and manually redraw them back in, which really sucks. And I think I accidentally did it, and like I opened up my CAM software, I'm like, wait, what just happened here? There's clearly a way. And I just exported it in every year, and I found it. I was like, oh my God, this is amazing. So the rule is, so you can't do Bezier curves, you can't do anything like that. You have to have an arc or a circle. And so if you're doing something, I actually just did a job where I had to cut on the CNC a whole bunch of oval tabletops. And they were, I could be like wrong on the technicalities of this, but it's like, it's an ellipse, okay? And so they sent me a file that was an ellipse, and I couldn't, and we had to modify, right? I couldn't export an ellipse out of SketchUp because that's essentially taking a circle and smashing it. And when you smash an arc, like with anything, with the scale tool, it automatically loses its radius, right? And so as soon as you scale something, you're game over. There's no more radius. But I needed this table to have perfect arcs because when you're cutting on the CNC machine, you don't want your machine going like that because I'd be sanding for weeks, right? And there's like a lot of these tables. I do not want to do this. So I traced in SketchUp around this ellipse using a whole series of arcs. And it doesn't matter how many arcs you have as long as they're arcs. So I think I had like 6 different arcs going around, and so I recreated the ellipse perfectly, and that exported fine, and I had no problems there. So you can't just like take something that was an arc and then like smash it. So you have to do like little arc, little arc, little arc, little arc to get it. Yep, that's it. So yeah, so there you go. Little piece of advice. So, all All right, so moving on, who's been down to the Knowledge Cafe? All right, anyone played in the arcade machine? Okay, so this is one of like my most favorite things that I built for SketchUp in recent years. So the way this thing went down, I had been. Did anyone see the foosball table we had last year? Okay, I don't have a picture right here, but I made. Actually, let's find it. Let's see, foosball. Let's just find that real quick because there's a funny story behind that one too. Do I have a? We'll open stuff. Let's see what's open on the internet here. Go back. Personal pictures. It's fine. There's probably some cat pictures in here. We're just going to deal with it. Okay, so I made a. So we were setting up a booth for SketchUp. It was an education booth. And the theme of the booth was supersized science projects. And we were creating these like little mini bits of curriculum that teachers could take away. So we did one, like when you made the DNA in school, like toothpicks and stuff, you make like the little spiral. We made like a 9-foot tall one of those out of PVC pipe because I had a lot left over from the geodesic dome. And true story, I had so much pipe left over. So I made this like spiral thing. And we made like a little curriculum around it, how you could download the 3D model and all this stuff. And I like to troll meetings a little bit. So we all know when we start SketchUp, we get the person standing there. And we kind of we had all the perimeter of the booth figured out. We didn't really have like a center thing yet for it. And I was like, you know what, we should make like a foosball table. I don't know why I thought of this. Like maybe I like encountered one, or in the day prior or something like that. So I took the scale figure, shrunk it, just like drew a table with 4 legs and just copied the person along some rudiment. It was like something I drew in literally 2 minutes. And I like put it on we were doing a shared conference call and I was like, we should make a foosball table. And I thought everyone's going to go, yeah, okay, cool, call over. And they go, yeah, we should totally do that. So I got a phone, I'm like, oh God, I have to make this now. And I've never done this and I have no idea how to do it. So this, it took me a while to figure this all out, but I modeled it in SketchUp, so CNC cut plywood box. At the time, the reason why this isn't here, this was SketchUp Make and SketchUp Pro were kind of the 2 different teams that were playing against each other. It was supposed to spark conversation about the difference between those 2. All of the players are all 3D printed scale figures from previous versions of SketchUp and people that work there. So this is really cool in our booth that like these kids are coming up and we're like, look, like that's Bryce, he's right there. You can go like talk to him, as they're using them to smack balls around on the table. So same story with this one. I extracted all of the vectors for the plywood cuts from the SketchUp model. All of the players were modeled in SketchUp and 3D printed from those SketchUp models on an Ultimaker, just like what's down in the Knowledge Cafe. And the rods, the hardware was actually a big deal because foosball tables are like there's like a whole governing body behind it, and it's like a whole thing. I thought it was like, a wooden box about this size, and we'll just put some sticks in it. It's like you have to get them like certified for competition use. It was like this is not certified, but I followed all the specs. But I had to buy the hardware. So I thought I was just going to use like plumbing pipes or something, but it turns out someone who is very good at foosball, who I know, was like, if you do that, that is blasphemy, and like you can't do that. He's like, get the real part. So I went on their website and I found all the specs, I modeled the parts, and I built this whole thing before any of the hardware showed up, and then the day the hardware showed up, it just fit because I knew all the specs. So this was like me trolling a meeting, and somehow the idea got accepted. So I got a little emboldened the next time around. And because this is the foosball table, pretty analog project, totally my wheelhouse. Vinyl stickers, wood, hardware. I'm like, once I broke the problem down, I was like, I can pull this off. So then I was like, SketchUp is fun. People like playing SketchUp. It's the closest thing in CAD to like a video game. I was like, we should put it in an arcade console. And they were like, yeah, you should totally do that. And I was like, okay, I guess I'm going to figure out how to do this. So this has all of the kind of basic SketchUp tools set up as arcade buttons. And so essentially this is like a big CNC cut plywood box. I'm jumping around in my slides here, but it was cut on this is my machine. So I cut out all the parts like that, again, directly from SketchUp models. And I wanted the buttons, whenever you push them, the idea is like, if you don't know anything about SketchUp, you press the pencil tool, the circle, the rectangle tool, push-pull tool, you can make models pretty quickly like that. And I wanted sound effects. So we were in DevCamp earlier this week, and one of the lead developers was like, I'm sorry if I don't get back to your emails. very quickly. We have a big workload, lots of tickets to go through, and I was like, I know how to get developers to respond to you really easy. So I emailed somebody in the dev team at SketchUp, and I was like, I need sound effects for the tools. Can someone write me a plugin to do that? And they were like, absolutely not. That is a ridiculous request. We've got real things that you people need to use that we need to fix. And I was like, but what if it was in this arcade machine? And they were like, yes, we will do that immediately. And I got a working plugin back in like literally 2 hours. It's a great way to motivate the developers. So just build an arcade machine and you'll get whatever feature you want in SketchUp. This whole thing, there was a lot of stuff that needed to fit together. The TV is in the back. I got the specs because I wanted to build the cabinet. I had all the specs I actually drew the TV in SketchUp so I could get all the blocking just right. TV showed up later, fit just right, which is very nice. And all of the other hardware, the buttons, the fog machine, which I'll get to in a minute, all of the wiring was all modeled in SketchUp. And my friend Brian at SparkFun, same thing. I wanted him to help me with the electronics, and so I sent him a layout document because he's a SketchUp user, right? Very, very engineered. He's like, I need to know what everything does, so I had to label them for him, give him all the diameters, and so he actually took my SketchUp model and laser cut a little test box with all the buttons in it so he could work out all of the electronics. Because he pre-built everything in Colorado, put it in a box so that I could take it out of the box and install it all in there. Including, we actually used the SketchUp model, this is not an exaggeration, to figure out the length of all of the wires that he needed. So everything was pre-cut, so it fit perfectly. I, of course, did a pretty poor job with the zip ties, and it looks like hell back there, but it all works. This also has this is the OMG, this is really hot. This has a fog machine in it. So I go to a lot of shows with SketchUp, and people like you come up and they want to fool around and draw things, and we absolutely love that, and that's why we're at these shows. But inevitably people mess up the toolbars. There's some wacky model in there, and then you got to go up and fix it all. And after doing it 10 times, you don't want to do it anymore. And then someone is coming up and they're like, I can't find the pencil tool. It's like, well, sorry, the thing's all jacked up. So I came up with this new tool. This is called the bomb tool. And so when you press that, this happens. You walk up. If this is going to work here. Here we go. Press that. And you sort of overload it. It blows up your model, and it completely resets SketchUp. So you're back to a standard model, and it emits all of this fog out of the bottom. So I came up with this idea. I modeled it in SketchUp. Where's the SketchUp model here? Where is SketchUp? I modeled it in SketchUp, and I didn't tell SketchUp that I was doing it. I just did it. And because I didn't want people to be like, well, I don't know, fog, it could be kind of distracting, anything like that. I just did it. So I actually modeled up all the pipes, figured out, because again, PVC pipes left over, and we want to keep using those. And put it all in there, and we got to the show, pulled it out of the box. It was like, guys, check it out. And they're like, are you kidding? This thing shoots fog? I'm like, oh yeah, it does. And so what was great is we had this thing in the booth. Everyone would walk by, and people, it's things blinking, and it rumbles and does all this stuff, so people kind of gravitate towards it. And a lot of people come by and go, oh my God, is that thing on fire? So I'm actually doing a similar talk to this one in a couple weeks, and the title is That Thing on Fire? But yeah, it shoots out a lot of stuff. So what you should do, Ty is down in the Knowledge Cafe. Just go hit that button a lot. Ty really loves all the smoke that's down there. And so again, there's a lot of fun stories behind this one, but this was all, there was a lot of back and forth with this. I don't have a picture of it right here, but this has been shipped around the country several times. And you don't just send something like this on a pallet, just sort of out in the open for a number of reasons. Trucking companies are really hard on stuff. And so I designed an epic crate for this thing. So the crate, I was actually trying to find the model this morning. I really don't know where it went, but let's see, hang on, is it here? No, okay, I think it's on a different computer. But so what I did was, this model is 100% accurate to the real one, down to every bolt, every nut, everything that's in there, and including literally the bolts that stick out the side, the amount that the bolt heads stick out of the side. So I drew a wooden crate to go around this thing with a fold down ramp, because this is on wheels, so that you can wheel the thing out. And there's foam inserts to keep it totally tight in there. And I cut the foam exactly the thickness so like the bolt heads go right up against it. And man, most satisfying thing ever, when you put it all together, you're like, oh man, is it gonna fit? Is it gonna fit? And it just goes, and it fits right in. And like that would not have been possible if I had not been able to design all the stuff in SketchUp and then cut it out on a really, really accurate tool. It fits incredibly tight. One thing that SketchUp does not do is figure out if something is going to fall over. And that is the story behind these little legs here. So I had an intern working in the shop at the time, and I cut out all these parts, and like, of course I wanted to like put this thing together as soon as possible, because I had a freaking arcade machine in the shop, right? So we pull all the parts off the CNC machine. I'm like, all right, okay, I'll get all the bolts. We're bolting this thing together. I mount the screen and I chuck the computer in the bottom and I turn it on. I'm like, yes, we have an arcade machine. And so I sort of walk up, and so it's on wheels. There's wheels in the back. So, and at the time, there was wheels in the front because I wanted to be able to kind of move it around wherever. So I walk up and I go, this is awesome. Then I kind of do that right on the console, and the thing tips forward right on me, and I caught it. Like, it almost crushed me to death. And I looked at it, I'm like, oh my God, this thing's gonna tip over. Like, this is a real problem, because what I didn't realize, I had what I thought was a big enough footprint, but when you have a wheel like that, it kind of moves in, the amount of footprint you have. So this intern I have in there, he's like, oh my God, this whole project is screwed. He's like freaking out. I'm like, don't worry about it, it's fine, I got this. He's like, what are you gonna do? So I went in here, I went to SketchUp, and I drew these legs. Like this, it was just like a super basic, easy SketchUp model. I drew them really quick, threw them in the scrap that was still sitting on the machine, cut them out, just went underneath, screwed them up into the side, perfect, no problem. And he was like, you could see, because once I figured out how to fix it, it was a 5-minute fix. And it was really, I really think I like changed his worldview that day. And because he was in the shop, like this is what he does in the shop. What he was doing at his internship was digital fabrication. And that was the moment where he's like, oh, I get this. Like, this is why you spend all of this time designing everything really accurately. I mean, you could certainly have cut this by hand. Any skilled carpenter or fabricator could do this, but it was much faster for me to do it and more accurate. So now you know when you walk over there and like, what are these little legs that you probably never would have noticed before? They are to prevent you from getting killed by this by this machine. So you're welcome. Do I have till 3:30 in here? Do you guys have any questions on any of these models or anything that I've done? I mean, I could keep showing more detail. Anyone's got? Yeah.
How do you make money?
I don't even know. So it's a very complicated answer. I build things in the shop. I build projects like this. I build a lot of boring stuff. If you take kind of these things away, I call it Eric's Rectangle Emporium. So any rectangle you want, any size, I will make it for you, and I'll make it really fast because lots of things are rectangles. Obviously SketchUp has paid me to make some of these projects, but these are sort of the big cool ones that happen over the years. But I'm normally in the shop fabricating stuff, and I'm currently working on making some software to make this process better, because after you get out of SketchUp, it's a little dicey after there, so we're making some things to kind of smooth it along. So, oh yeah, go ahead.
My question, your workflow. So you've got this model, you broke out all the pieces in one of your images you have.
Yep.
And then you said you export those individually as 3D vectors.
Yeah, these are all the sheets I cut out for the arcade.
I mean, you literally take each piece, kind of nest them, export that, and then where does it go?
Yeah, that's a really good question. So it really depends on the machine, but in the case of the CNC machine, because we can all kind of visualize it because it's right here. So the machine I have is a 4-foot by 8-foot. So you can put a full sheet of plywood or any other material on the bed. So in the SketchUp model, I have drawn 4 by 8 sheets of plywood, and I take all the parts and I lay them out individually. Now there's a way in well, I'll get to that in a second. So I lay all the parts out and I export that 3D DWG file. And so you can't just put a DWG directly into a machine like this. You have to bring it into what's called CAM software. So CAD is computer-aided drafting, CAM is computer-aided manufacturing. So you bring these 2D vectors in there, and like for the case of the arcade machine, you would say, look, this vector that's going around the outside, cut around the outside of that. Wherever there's a bolt, you see a circle, you say every circle, drill a hole in there. and so on. So it's a little, that part's actually pretty tedious. It's a lot of elbow grease, as I call it. So, and this is why I do all the smart work in SketchUp, so that when I'm in the CAM software, all I have to do is kind of just select everything and just like tell it what to do. I'm not making any drawing adjustments or anything in there, even though I technically could. So once you do that, in the case of CNC, you create something called G-code, and it's essentially just moves. All this machine does, like these things look like complicated, crazy robots. It's just, it can move left, it can move right, and it can move up and down, and that's kind of all it really does. So it's just like a big text file that just says, go this way, then go that way a little bit, then go that way, and then go like this, and drive over here and drill a hole, and that's really all it does. So the process, and this is not like because I'm like super pro SketchUp and I don't like these other programs. SketchUp is a great place to keep all of this information together. I really, really, really can't deal with like, well, this is a concept drawing, but in the CAM, like the real profile's over there. It's really, in my head, it's really got to all be in here. And whether it's CNC or 3D printing or vinyl cutting or sewing or whatever it is you're doing, anything else down the line, it's pretty tedious. And I just say it's a lot of elbow grease. If you make your export out of SketchUp good, then you're just like rinsing and repeating down the line. And it's a lot of work, but it's less hard to make mistakes, if that makes sense. It's kind of a long answer.
Each one of those is its own component. Turn everything off, export that.
Yeah. Yeah, it's essentially stripping away only stuff but the essentials. Like, I don't need to export this hinge, right? Because I'm just going to put that hinge on there. Question in the back.
Two, actually. One, you cutting the rubber for the soundproof phone booth? I'm curious what tooling you use, what actually did the cutting?
Yeah, good question. So I used I used one of these things. It's called a drag knife. It works like this. I hope this doesn't have some bonkers music in it. We'll find out. So basically, for those of you who don't know how a CNC machine works, it's like that kind of robotic arm thing, and there's a spinning bit that can drive around and cut material out. Don't try to cut rubber with a spinning bit. It won't go well. So you can take the bit out and you can put what's called a drag knife on there. So all this is, it's a holder for like a utility knife blade. The blade is a specific distance behind the center point of where a regular router bit would be. So you can plunge it in the material and you can just kind of drag it around. And the CAM software has a little mathematical equation that will sort of figure out how to kind of wiggle it around. And this is like, it's kind of funny. My woodworker friends come into my shop all the time, and they go, "You really have garbage tools," and they're right, because like my table saw is like real bad. I've got this like pretty busted drill press, but like the CNC machine is like I do everything on that, including I made cardboard boxes one day. I swear to you, so I work in the building I work in. We've got a candle maker on the other side. They have tons of cardboard boxes. I always get to go over and pilfer cardboard if I need it. And I get these big sheets, and I had to ship a piece of furniture, and like I just couldn't like come up with a way to wrap it really well. I was like, man, if only I had a giant cardboard box. And wait a minute, I can make my own cardboard box. So I went into SketchUp, I drew a cardboard box with all the flaps. I used this thing and I cut it out, and it's got a roller you can put in there too, so you can make the creases. And I pulled out this like perfect cardboard box and folded it up. And I remember Megan came by and she's like, "What are you doing?" I'm like, "I'm making a cardboard box." And she's like, "How long did that take?" And I was like, "Way too long. I spent 2 hours making this. This was not cost effective at all. But like, I made my own cardboard box. It was so cool." So.
How do you design that geodesic dome?
So I leveraged 3D Warehouse pretty heavily. So there's tons of geodesic domes on 3D Warehouse. And let me see if it might still be in the model. But you just type in geodesic dome and you get a ton of things. I was a little worried that like I didn't want to use something that maybe wasn't truly a geodesic dome. So I found a modeler. His name is it goes by Taff Gotch. If you are here, I want to meet you. But he's really obsessed with geodesic domes and uploaded a ton of them to 3D Warehouse. He's like a mathematician or an architect or something, writes about them, and is just really, really into them. So I kind of, his models were really good. They were really accurate. And they were like just surface models in SketchUp. So he had like all the lines that I needed. It actually might be in here. Let me see turn on hidden geometry. Is it still in here? No, it's not. So what I did was, so if you can imagine like just a low poly sort of geodesic gnome, that's what a lot of his drawings were. And I think he would give these models to students to study like the different tessellations of gnomes. They're very simple. So I was able to take Profile Builder, the extension, and turn all of those lines into pipes. And so actually, I remember the way I did it was I looked at his models, I read about geodesic domes, and I understood that a 3V dome has 3 different lengths of pipe. And then I found some random extension somewhere that you could select similarly lengthed lines. So you could click one line, and you could say, find all the lines that were the same length. And like, I remember, I was like, I Googled that. I'm like, oh my God, of course an extension exists for this one thing. I don't think I've ever used it again. And so it allowed me to take his model and sort of confirm that it was modeled right based on everything else that I had read about these things. So once I found like there's yellow, blue, and red pipe. So like red pipe is a certain length. I found all the lines that were that length. Put those all in a group. Then I found all the ones that were the second length and put those all in a group. And then I started going in those and drawing components. And I literally used a 3D warehouse model as a template to build this dome. So like, thank you, other smarter people than me and 3D warehouse.
Back on your, well, just about any project you got there, but mostly I was thinking about the video game. How much percentage of time do you have in design and layout versus production?
So that's a really good question. I'm very glad I did not log hours on that one because I think I would realize that I paid SketchUp to make it, but that's okay. It's 90-10, okay? So when I came up with the idea for it, I found some arcade machines that were kind of my inspiration, and I started with just a really basic profile, and I kind of extruded it, and I was sort of getting a feel for the size and the height. That's super easy. Splitting it up in wood panels it was actually pretty easy because it's just flat. I mean, CNC stuff's just flat panels. It's really, you can break it down, it's not that complicated, modeling-wise. And putting it in the shelves, figuring out, because like it's a giant open cabinet. So a lot of the stuff that went inside it, like there's computer speakers and a subwoofer and a tower case. And most of that stuff was like, can I fit a tower computer in there? Yes, I have 5 extra inches, so it doesn't matter if I get this Dell or that Dell, right? So a lot of that confirmation that goes really, really fast. The last 10%, which was like on the doors in the back, the hinges call for a very specific reveal for them to open and not bind in there. That's really tedious because you got to get it just right because there's little cups in there where those hinges go into. Things like I drilled holes for the casters to go in the bottom. And like I had to get casters and like put calipers on them and then draw those 4 holes in SketchUp. And it's like, that sounds super tedious, but I do all that stuff because it's in the model. And when I cut out all these parts, like I literally cut those parts off of that machine, from the machine, and I had a helper. I took all the parts off and we had that cabinet standing up in under 30 minutes. It wasn't painted or wired or anything like that, but it was standing up in 30 minutes. And the reason why I spend, so that last, like the little reveal and the holes for the caster, that's that 10% that took almost as long as the whole concept. But I do all that stuff because like lining up a caster and drilling 4 holes, that takes some time to like do it right. And I didn't have to do it, I just like put it together. And actually in the case of that caster, there were bolts in the floor. I had to replace the floor because of that leg thing that was in there. I wanted a little more meat underneath there, so I made a new floor. Really easy. I just like loaded the file and threw some scrap in there and ran it again. And I didn't have to do that work over and over again. So I really, really try to you know, because I'm doing digital stuff, try to load as much in there. But it kind of falls under 90-10 rule. That last 10% takes as long as the first 90%.
Is there a better new experience, a better CAM program that works best with SketchUp?
So the one that I use, do you run a CNC machine now?
So just now we're looking to buy one for the very beginning stages.
Okay, come see me after. I'll help you with if you have any questions. But there's a really popular one called Vectric. They make VCarve, Spire. They work with a ton of different CNC machines. They actually work with SketchUp to get a SketchUp importer. And there only works in SketchUp 8 in 2013, but you can downsave for that to work. But there's tons of those programs out there, but I can talk to you more after. But I think we're done at 3:30, right? All right, well, guys, thank you very much. Enjoy your Basecamp and the rest of the afternoon. And go play some cornhole tonight.